Okay, here's the second example of graphing rational functions with slant or oblique asymptotes. All right, so the first thing I'm going to do is find my overall degree. So up here in the numerator, I have x squared. The denominator, I have x. So my overall degree is 1. Leading coefficient, 1 and 1. So again, 1. The overall degree is odd. That's going to help me graph my function. Leading coefficient is positive. Again, helping me graph my function. So since the leading coefficient is positive, I know that the end behavior will be in quadrant 1 on this side. And since it's odd, I know that the other end behavior will be in the opposite direction. Since my overall degree is 1, that means I'm going to have a slant asymptote. In order to find the equation for the line, I'm going to need to do some long division here. So I'm going to take my numerator and divide it by my denominator. So x, so this will be x squared plus 2x, and remember I'm subtracting. So that gives me negative 8x plus 9 as I carry it down. And then to get rid of this, negative 8. So I'm going to subtract a negative 8, which is positive 8. And then I actually don't need to finish this. I don't need to get my remainder. All I need is the equation for my line. So y equals x minus 8. So I'm going to have a slant asymptote at y equals x minus 8. Okay, zeros. Zeros are where the numerator is equal to 0. So we're going to have to factor this. So I'll put this right here. So x squared minus 6x plus 9. Threes. So if I'm going to look at this, it is a perfect square, because negative 3 squared is 9, and negative 3 times 2 is negative 6. So I'm going to have a 0 at positive 3, and it has a multiplicity of 2, so it's even. I do not have any holes, because there's nothing in the numerator and the denominator that cancels, so none. Vertical asymptotes where the denominator equals 0. It's going to be negative 2, and that one's odd. All right, let's go ahead and graph. Make sure I stay on camera here. There we go. All right, so, and I know I have a y-intercept here of negative 8. All right, so let me just put that there for a minute because I'm going to have to graph this. So a slope of positive 1 all right. So my slant asymptote or oblique asymptote is at y equals x minus 8. I have a 0 at x equals 3. 1, 2, 3. And it is even. Make a mark there so I don't forget. And then vertical asymptote at negative 2. And this is odd. It's odd again because the power is 1 here, so the power of 1 makes it odd. All right. I know that my end behavior has to get closer and closer and closer to the slant asymptote, and that it is going to be in quadrant 1. So I have end behavior, and then I need to come down here, and this 3 is even, meaning it touches or bounces off the x-axis, and then continues to the next asymptote at negative 2. This is odd, odd meaning opposite. That's how we remember it. So this is pointing up, which means the end behavior down here is going to be pointing down or negative. And then as I move to the end of the function, my end behavior has to get closer and closer and closer to y equals x minus 8. And I just realized I'm off camera. So there we go. All right, so I've got my end behavior down here, getting closer and closer to my slant asymptote at y equals x minus 8. And then my end behavior up here doing the same, getting closer and closer to my slant asymptote. And I have my spot where I bounce or touch the x-axis at the 0, 3. And then I have my vertical asymptote at -2.